Hello, we back with a new video. In this video, I will show you how you can use some age detection algorithm in order to detect the ages in your image. Okay, let's start with the code. Uh, Similar to the previous codes, we need some module or some libraries. Here we use the IOStream library, core library that used for the basic calculation, HiGUI for read and show an image, and image processing for using some filters or algorithm that is available on this library. And also we use some namespace, CV or std in our work. Okay, first we have to load our image. As you remember, I told you that we can use any extension of the image in the OpenCV such as BMP, TIFF, JPEG, PNG, and whatever you like. But for example, we can use here lena.tiff in a grayscale. Okay, we can write a sentence or just finish the codes if we cannot load this image. That there are several reasons for doesn't upload the doesn't load an image. For example, the image is not existing in that the folder, or the image is cropped or something like this. We can write a sentence or just finish the code, and we can show the original image here. First we have to introduce a new windows original image, then with the imshow we can show the image in these windows. Okay, as you know, one of the popular age detection algorithm is Sobel age detection. So I will show you how you can use this algorithm to detect the ages in your image. We can extract or we can detect the ages in X derivative and Y derivative or both of them. First, let's start with the ages in X derivative or in the X direction. First, we have to make a new variable of the class of math for the output image. We can use a Sobel command, that's the built-in OpenCV function, the input image, that's the original image, Sobelx, that is the output variable. We can use this library CV16s, and we need it in the X derivative. It means that we have to put 1 here for the X and 0 for the Y. And also we can use some variable or the window size, for example 3 by 3 or something like this here. You can change it in order to get your desired result. So we can use the Sobel X image. It's the result image after applying the Sobel function on this, and show it in the Sobel X image windows. Okay, if I run this code, it will show us original image and, excuse me, let me to show you Sobel X image. As you can see, it returns some ages, but maybe you can see it, but it returns some ages in the X derivative. And later I will show you how you can optimize this algorithm to see more ages or to get better visible edges in your image. Okay, similar to the previous one, we can detect or extract edges in the y derivative, but here instead of putting 1 here, we have to put 0 because we want to return the y derivative edges, or edges in the y direction. Also the size of image and other criteria. And we can show it on this Windows Sobel Y image. Okay, if we run it, you can see original image, X image, and also in the Y derivative it returns some images similar to the previous one. You can see this image, these edges, but it retrieves some edges in the y derivative. And also we can use both of them, or we can show both of them, or detect both edges in x derivative or y derivative. By this we can add the result of Sobel y to Sobel x, the absolute value of them, and retrieve this and show it in the new windows. Before running these parts, let me to talk about the optimized version of the Sobel algorithm. Then after that, at the end, I will show you all the results or all the images. We can use a scar or Sobel character instead of the Sobel comment. Here it returns the optimized Sobel algorithm. Okay, we have to define some variables, new variables of class math for new results. Here image and new variable for the results in x derivative, and the size of the windows we will show it in this window. And for the y derivative, we can write 0 for the x part and 1 for the y part, and the same comment. Okay, and we will show the result in this windows. And if we want to show both of them in one window or in one image, we can add, similar to the previous one, we can add the results of the x derivative and y derivative together and show the all edges in your image. And at the end, we can use wait key to wait till we press any button to finish the codes and return 0. If we run the code, we can see the results. Original image, okay, it's the result of the Sobel, optimized Sobel in x derivative. Both of them, x derivative and y derivative, and the detected edge in y derivative. We can see if we add these two results, we can return this one. And also if we just use the Sobel function, not optimized one, in both of them we can see these results. Y derivative, x derivative, it's not more visible, but it returns some edges here in the middle and here also in the middle. And if we add both of them, we can get this result that is not, the typewriter is not visible for you, but we can use the optimized version of the Sobel by using the scar function. Okay, that's it for this video. I will see you on next video. Bye.